Hello, Algebra 2 triggers. We're moving on to 6.6 and 6.7 today. And so when I see you again next week, we'll finish the chapter. Then you'll have your review for the test on Wednesday, and the test will be next week, Friday. So 6.6 and 6.7. 6.6 is just a really quick kind of recollection of things you've learned in the past and trying to put things together as far as what is a rational number and what is an irrational number. So we have real numbers. Well, real numbers are all numbers that are real and not imaginary. So the second section today, 6.7, is about imaginary numbers. So all numbers that are not imaginary are real, which is pretty much all the numbers that we've talked about so far. And in the real numbers, we break down into categories, two categories. We have rational numbers and we have irrational numbers. So rational numbers, what is that? Well, a rational number is any number that can be expressed as the ratio or quotient of two integers. So in other words, can it be expressed as a fraction or a ratio, right? That's why it's rational, a fraction there. So some people look at repeating decimals like 2.151515, etc. And if I just put a bar over the 1, 5, that means it's repeating forever. And some people think, well, if it's repeating forever, it must be irrational, when in fact that is not true. So if you have an old TI-84 or TI-83, you could literally type out 2.1515151515, fill out the entire row, and then push math frac, and you'll get the answer. The answer is 71/33. Or you could figure out the fraction equivalent by a little algebraic way of doing it. And if you're interested in that, then just look in your book in 6.6. You will never be required to do that. We're not going to assess it. But if you are interested, you can go ahead and check it out and then ask me questions if you are confused about what they did to find that fraction equivalent. You might have done that in middle school math or something as well. Okay, so whatever is not a rational number must be an irrational number. So a rational number can be written as a ratio or a fraction, and terminating and repeating decimals are examples that can also be written as a fraction. The whole number 7 can be written as a fraction, right? 7/1, 14/2, etc. A negative number can be written as a fraction. -3/1, -15/5, etc. So an irrational number is any real number that is not rational. So it means that the decimal representation of an irrational number is neither repeating nor terminating. So in other words, the decimal goes on forever and ever and ever, right? So your decimal never ends. However, when you calculate things, your calculator makes it look like it's going to end. So this is very important, this note right here. Your calculator gives only a rational approximation of the irrational numbers since your calculator's display is finite. Your calculator obviously can't spit out an infinite amount of numbers, therefore it only spits out 12 decimal places or 10 decimal places or however many you make it spit out. So it gives you a rational approximation. So an irrational number is any number that has a decimal that goes on forever and ever with no pattern, it's infinite, and it doesn't repeat, it doesn't terminate. Alright, so use those definitions to determine whether or not these are rational or irrational numbers. So I want you to pause here and try to figure this out. So pause, put an I or an R next to them, and then come back if you want explanations. Okay, so you should be back. So first one, irrational or rational. Well, it's a fraction. And obviously this fraction terminates if we were to, or maybe it doesn't terminate, it repeats. But this is a fraction, it's in fraction form, so this is a rational number. Right? And usually we do Q or not Q. But I'll put an R or an I. So you can either do Q and Q not with a bar on top, or you can do R and we'll do I. That's actually really bad. So we'll keep it as Q and not Q. Okay, so the symbol for rational numbers is a q. This is an integer, -7. All integers are rational numbers, right? We can rewrite that as a fraction, -14 divided by 2, -21 divided by 3, -7 divided by 1. If we can write it as a ratio or a fraction, it's a rational number. This decimal ends, right? It's a terminating decimal, so this must be a rational number. Okay, what is the square root of 0.01? It's just 0.1. So you simplify these radicals, and if you get a terminating decimal or a repeating decimal, then it could be rational. So this is just equal to 0.1, so therefore it is rational. The cube root of 8, well, the cube root of 8 is 2 times 2 times 2, so the cube root of 8 is just 2. So it must be rational. The cube root of 9, well, 9 is just 3 times 3. It's missing a third 3, so therefore it is not a perfect cube. And underneath your radical, if you have a non-perfect square underneath the square root, or a non-perfect cube underneath the cube root, or a non-perfect fifth underneath the fifth root, then those are examples of irrational numbers. So it's q with a bar on top, so that is irrational. So if you were to plug that into your calculator, if you did the cube root of 9, right, you get a decimal. My calculator gives me the decimal of 2.080083823. Well, it stops on my calculator, but that's only because my calculator can't spit out the infinite amount of decimal places that go on. So therefore, it gives you the rational approximation, as it states right here. So even though it stops in your calculator, don't be confused. That's still an irrational number. Okay, so the irrational number, I'll circle in red. Okay, let's look at 7. We simplify. The square root of 16 is 4, square root of 25 is 5, therefore it's a rational number. Okay, number 8. Number 8 is irrational. How do I know that? Well, I have the square root of 2, and 2 is not a perfect square. Therefore, this is going to be a never-ending decimal, and a never-ending decimal divided by 2 is still a never-ending decimal, so this is irrational. Pi, you should know by now, is a decimal that goes on forever and ever. Yes, some textbooks in the past might have told you that 22/7 is an approximation, but it's not the exact value. There's contests all over the world every year to who can memorize the most decimal points of pi. So it goes on forever and ever. It's an irrational number. So therefore, if you see a problem with pi in it, it's an irrational number. Here, look at this one. 2 root 3 times 2 root 3. Well, 2 root 3 times 2 root 3, 2 times 2 is 4. Root 3 times itself is just 3. So that ends up being 12. So this is rational. Okay, but what about 2 root 3 to the third power? Well, that's 2 root 3 times 2 root 3 times 2 root 3. 2 times 2 times 2 is 8. Root 3 times root 3 is 3. And then we have still a singular root 3, which we can't simplify. So this becomes 24 root 3. Well, if you have any kind of radical in your answer that can't be simplified, then it's an irrational number. So the irrational numbers are here in red, 6, 12, 10, 9, and 8. The others are all rational. Okay, now the next row. Tell whether or not each number is real. If it is real, tell whether it is rational or irrational. So real means that you can actually calculate the answer. So the square root, that if it's real, then it does exist. So if it's real, then it does exist. So the square root of 1,000, does this number exist? Yes, you can punch in the square root of 1,000 on your calculator and it's going to give you an answer. Is it going to give you a decimal answer, a never-ending decimal, or is it going to give you just a singular fraction answer? Well, 1,000 is not a perfect square, so therefore, right, that's 100 times 10. So the simplification of the square root of 1,000 is 10 root 10. So is it real? Yes, it is real. Is it rational or irrational? Well, it is irrational, right? So because we still have a radical in its simplified answer, then it is irrational. The square root of 10 it's not a perfect square, so it goes on forever and ever. Okay, how about number 2? Can you take the square root of a negative number? Not yet, not until we do this imaginary stuff. So therefore, this is not real. It is imaginary. Oops, I'm writing what I'm saying. It's not real. We're going to learn how to simplify that here in the next section. Okay, what about the square root of negative 1,000 squared? Well, remember when we did that square root of x squared, that's going to be the absolute value of x. So this is going to be the absolute value of negative 1,000, which is 1,000. Right? Because we would square negative 1,000 and then take the square root, so we'd end up with 1,000. So yes, this is a real number. Sorry, it is a real number, and it is rational. So it's real and rational. And finally, number 4, can you take the cube root of a negative 1,000? Well, yes, you can take the cube root of a negative. That would just be a negative on the outside, right? So it's negative 100 times, or sorry, my fault. Let me re-explain that. So it's negative 10 times negative 10 times negative 10, because it's a cube root. So is 1,000 a perfect cube? Yes, it's 10 times 10 times 10. Therefore, negative 1,000 is negative 10 times negative 10 times negative 10. So my answer is negative 10. Is this number real? Yes, it's real. And is this number rational or irrational? It is rational. So number 4 is real and rational. Okay, so that's it for 6-6. You can go through your book and read more about it if you want to, or ask me questions. If you're not sure, then pause the video, ask questions, and I will clarify for you. Oh, sorry, I'm not in the room, so I can't do that. Kidding. I forgot it's a sub today. I'm confusing it with last class. So don't ask me questions next class. I'll answer them before we do move on, so you can ask me then, but go ahead and try the homework and see how it goes. All right, next video we'll do 6-7.